we talk about the electric 2 and 3 wheel solutions. We know electric 2 or 3 is very big market in India and also in China. In Indian market, 2033 years, the total sales quantity is 0.7 million units. It's more than and double for the 2021 years. It is only 0.25 million units. And the top 3 concentrate in these 3 suppliers. It occupied 46% in 2023 years. When we check the electric 2 wheels, the broad diagram is like this. As for the power control unit, it comes from the batteries. It can do the DC to AC for the motors and use the DC-DC converter converted to 12 volt supply to the lightings front end and back end. And this price battery would need a BMS to management it. As for the key switch, when it turns on, and the battery will need a board charger or onboard charger to charge the electric to it. As the 3 wheels is similar with the 2 wheels of the broad diagrams. If we see the onboard chargers for these sections, this is the AC to DC, the PFC sections like this. There will be a bridge here to do the converter AC power to the DC powers. For the 7050 watts chargers, the bridge will use 600 volt and ampere the GPU packages like these TSD parameters. As for the higher powers, 2200 watts, it uses the 100 volts and the output voltage is bigger. The TSD solution like this. As for the PFC diode, it can to the 750 watts. It will use the TL220 packages, and 600 volt and ampere TR will be 35. You can use the parameter like this. As for the big powers, no more use silicon carbide shocks. We can choose 600 volt, 20 ampere, and TSC solution like this. As for the bypass diode, yes, it can, in order to retrieve forward surge current to damage the PFC diode, while the turn on FSM is constant. So the 750 watt chargers, you will choose 600 volt and amperes. The TSC parameter this. For the 2200 watts, it will use 610 ampere. TSC parameter like this. As the PFC switching MOSFET, those 750 watts will use the 650 volt RDS on 110 milliohm. TSC solution like this. As 2200 watts, it will use the 2 parallel in using the 600 watt RDS on 80 milliohm. We TSC have solution like this. As the LCD-DC, this is a half bridges. It's for 750 watt chargers. This half bridge MOSFET, it will use 650 volt, RDS 110 milliohm. Solution like this. The synchronous switching MOSFET here, it will use because output is 60 volts, so it will use the MOSFET 150 volts, RDS 10.5 milliohms. If the charger, the power is bigger, 2200 watts. For the LCDC/DC side, use a full bridge topologies. So the cool in MOSFET we use 650 and the RDS on 30 milliohm. So we have the closed solution like this pattern burst. As for the output Shakis, it will use the 200 volts, 20 ampere. It uses 3 pieces in parallel. We have solution like this pattern burst. As for the bootstrap diode, you can charge capacitance where the lower MOSFET is turning on. Then provide the high voltage MOSFET get driver voltages. For the bootstrap diode, we use the 200 volt and 1 ampere DC power like this. As for the voltage reference, here it will use the conjunction with the after photocouple to provide feedback loop to the isolation feedback. And the TST have power number here. As for also power, it will use the feedback topologies, convert 40 volt to 12 volts. This also power. It is the feedback MOSFET. Use the 650 volt, RDS 110 milliohm, and our solution looks like this. As for the secondary side diode, it used the Shaki 150 volt 3 ampere TSD's reference parameters here. For this RCD diode, this will use the 600 volt 1 ampere TR 250 nanosecond TSD solution like this. As the auxiliary diode like this. We have the 600 volt 1 ampere, and the reference power is like this. And here's the reference, voltage reference, and here's the solution, it's like this. And for the BMS side, we have the IS4825 transceiver isolation powers. Usually, it will use the push-pull converter to avoid interference to affect signal integrity. So the push-pull diode we can use 40 volt, 25 ampere. It will be reached end of this year. And the IS4881, it will connect LDO because it can provide stable and load independent power to prevent this to be out is this transceiver's supply range. So we use the LDO 5 volt output, and ampere is 150 milliamp. DSD have the reference parameter here. As the TSD transceiver digital signal isolation. This is They have the solution, the VZT here, the UART, TS, and RS signals. It's logic 1 to enable transceiver and if no need. Micron signal enables to use VZT here. 160 volt and PNP signal. As the ESD protection here because RS 485 transmits bits 10 mega. It includes half duplex differential signal A and B. The transceiver logic 1 is and the logic 0 is depend on the A and B differential voltage range. So it will use the ESD with needs 12 volt and 7 volt bidirectional. As for the CAN bus transceiver digital signal isolations, because the CAN bus is 2-watt differential communication interface, its CAN high range is 2.5 and the CAN low is 2.5. It will need considered both jump start test. So usually it's working voltage low mounted high. Less than 30 picofarad. TSC solution like this. As the cell balance, the AFE power and passive balance. Now this one is use this circuit to charge and discharge each the iron batteries. So there is the battery die to supply AFE power via this switching diode. And this switch on 200 volt, 0.2 ampere, it will release the energy of TSC. As for the TBS, the FAV battery, the surge protection, usually it will choose the battery voltages. The battery voltages plus 5 and 10 volts. So we'll use the working voltage 25 volt, unit duration 600 watts, like this parameters. As for the battery cell switching MOSFET, it release overall voltage consumed in this resistance. We'll use SOT23 packages, 30 volt and 3 amperes. TSD has no solutions. The Xena is protect the MOSFET VGS. We will choose small single Xena 50 volt. It will read and receive. And the Shaki here is a DC-DC supply. Step down the battery voltage to 12 volt. And this could cut off all the power for the power lower dissipation purpose. We'll connect the MOSFET here. It's used 100 volt, 1 ampere. 10 is no reference as for this Shaki. The protection Shaki. It could prevent the abnormal. We use the 100 volt, 2 ampere SMB package. TSC reference parameters here. As for the DC-DC supply, there is the Xena to protect MOSFET VGS, small signal 12 volt, release 2024 NWC. And there is the step down free wheel diode here. This could choose 100 volt, 2 ampere, TSC reference parameter here. As for the BMS, another section is charge and discharge switch for this back-to-back MOSFET. It could have charger to cell battery or cell battery discharge. So it usually choose 100 volt at the S3 mini ohm. This is no solutions. And the TVS to do the surge protection from the adapters. This we can choose the battery. It usually choose the battery volt plus 5 to 10 volt. So we can choose working point 24 volt and like these parameters. And for this MOSFET, we can add a Xenon to protect the MOSFET VGA to choose the small signal VZ 15 volts increase and VST. As this VJT, it can speed up MOSFET switching off time. It uses the PNP transistors. If the 2 and 6 parallel MOSFET driver circuit can provide enough current to turn on MOSFET, usually we add this VJT here, PNP. This is no solution here. But for the Schottky to do the radial voltage functions, you can use the 100/1 ampere TSC reference parameter here. The power control unit, the 3-phase DC motors. The MOSFET would choose to do the 3-phase DC motor drive switch. Usually they will use the 100 volt RDSM very low, 2 milliohm. As for the TVS, the motor back entrance attachments, use the needed. It will use the 50 volts and the breakdown voltage to 7.8. As for the DC-DC converters, the battery 48 volts step down to 12 volts for the clusters. There is a Schottky here, step down very weird diode 100 volt 2 ampere TSC reference parameters there. As for the lighting, the headlight can step down 12 volt for driver single or multiple LED diode. You can choose our step down LED drivers like these parameters. And this freewheel diode can use our Schottky like these parameters. As for the tail light, to do the brake, reverse, and turn light, you can use our three channels parameter like this. This is